Hello and welcome to another session in physics. In this session we'll be looking at the topic safety device, fuse. But before that, let us review the previous lesson. Welcome back. Now, what is a fuse? Well, a fuse is a protective device that has been designed to melt at the passage of excess electric current through it. You can see the diagram here, what it looks like, and this fuse can be found in so many electrical appliances today. We can find it in the socket head of our televisions, socket head of our laptops, socket head of our pressing irons, socket head of our DVDs, and so many other appliances that we use in our houses. Sometimes, due to the fact that we are using AC current, there are bound to be fluctuations in the level of current. Sometimes the current is excess, high current, and sometimes the current is too low, which is known as low current. So what this fuse does is that it helps to protect the device because it has been designed to melt once it detects the presence of an excessive current trying to flow through it. The effect of this is that it helps to protect the electrical device. So instead of having to buy a new TV, for instance, because an excess current destroyed it, all you just have to do is replace the fuse or replace the socket head that housed the fuse. Alternatively, we can also define a fuse as a device that opens a circuit by means of a conductor that has been designed to melt when an excessive current flows along it. Now, this conductor inside the fuse, as you can see from the diagram here, this is a melted fuse. This is a thin conductor. This conductor, actually designed to melt, is what we call a fuse element. So a fuse element is an element found inside a conductor, inside a fuse rather. It is a conductor that has been designed to melt at the presence of an excessive current that has been made to pass through it. At this point, let's talk about the current rating of a fuse, which is also known as the fuse rating. If you've ever seen a fuse before, look at it critically again. You would notice that most times on it is written 13 AMP. 13 AMP means 13 amperes, and this is the minimum current which the fuse will carry for an indefinite unlimited period of time without that fuse deteriorating. In other words, this is the minimum current that this fuse will be able to allow to pass through it for an unlimited period of time, and nothing would happen to the fuse element. The fuse element would not melt. But if an excessive current, say for instance 18 amperes, was introduced into this fuse, after a short period of time the fuse element will deteriorate. In other words, it would immediately melt. So the current rating of a fuse is the minimum allowed current which will pass through it for some time, and the fuse element will still remain intact. And now we have what we call fusing current. What is fusing current? Well, when we talk about fusing current, we are simply referring to the minimum current which will cause the fuse element to heat up and melt. Melting means it would either rupture or it will blow up. So this is the minimum current that will cause the fuse element to heat up and melt instantly. Could be 18 amperes, could be 15 amperes, whatever has been designed for the fuse, because fuses come in different sizes according to the appliances that they are made to protect. Now we also have what we call fusing factor. Fusing factor is defined as the ratio of the fusing current upon the current rating. In other words, it is fusing factor equal to fusing current over current rating. So already we've defined what we mean by the current rating, and we've also defined what we mean by the fusing current. Remember, the current rating is that which is written on the fuse itself. You're going to have it as your denominator, while the fusing current, that current that will make the fuse to melt instantly once it is introduced into the fuse. Both of them, their ratio together is what gives us the fusing factor of any particular fuse. Now we have so many different kinds of fuse. The first one we want to talk about is the fuse we call the rewirable fuse. As you can see here on the board, rewirable fuse. This rewirable fuse sometimes also acts like a circuit breaker. It is a circuit breaker because once you see this one here is a handle, if you pull it out, what happens is that the entire building loses electrical supply. There is no more light in the building because the fuse has been cut, the circuit has been broken. But when you plug it back in, light is restored. So this one mostly is used in homes and offices and sometimes industrially too, to complete the circuit from the high tension or the pole down into the house. It is most times situated alongside the meter, which helps to calculate the electrical energy or electrical power that is being consumed in the house. Alright, the second kind of fuse is the one we call cartridge fuse. Cartridge fuse. Now this is the fuse we see in electrical appliances such as our pressing iron. We see them in our TV, in our radio sometimes too, in our cable decoders such as our GoTV, our DSTV and so many others. This fuse protects these devices in the event that there could be the introduction of an excessive amount of current. So instead of our TV, for instance, spoiling or destroying entirely, what happens is that the only component that gets spoiled is the fuse, and the fuse is located on the socket head, that part of the device that we plug into the wall. Say this is our TV, for instance. The wire itself and the ports where we plug into the wall, you find this fuse there. So what happens is all you just have to do is replace this head and you're back in business. Now we also have the high breaking capacity fuse. Now this high breaking capacity fuse is one of the most effective fuses we have because it has a high capacity. It can tolerate a very high amount of current passing through it without it deteriorating. The reason for this is because it has been specifically designed for this use. So most people prefer to use this in the construction of some components, devices, in fusing buildings and so on and so forth, because it has a high breaking capacity. It helps to tolerate high amounts of current without having any issues at all whatsoever. In fact, you can see the voltage is very high. It tolerates voltage of at least 550 volts. Alright, so how do we detect faults in an electric circuit? There are so many ways we detect faults in an electric circuit. If an electric circuit is faulty, probably it causes electrocution, or it does not really deliver currents the way it should be, or the amounts of current, probably just the neutral part of the current is showing and the live part is not connecting at all. One of the ways we can do that is through the measure tester insulation resistance test. So we have to use an ohm meter for this. You can use an ohm meter for this to do the insulation resistance test, or you can also use your multimeter for this as well. Measure test. Another kind of test that you can run is the test we call the test bell. Test bell is also known as the polarity test. Now when we talk about polarity, we're referring to the positivity or the negativity of the two terminals. We know full well that two colors used predominantly in electric wires or conductors are red and black. Red is always known to be positive and black is always known to be negative. But if there is a fault in a system, sometimes the polarity changes. The negative becomes the positive and the positive becomes the negative, and this can result in serious electrical faults in a system. So we use the test bell or the polarity test to identify this fault. Another kind of testing that we use to detect faults in an electric circuit is called the earth loop impedance tester. It is a kind of test where we have to test for the effectiveness of the earthing. Was the building earthed properly? Was the device earthed properly? So we use the earth loop impedance tester to confirm these facts. And then we have this one that is so popular, the continuity testing. In this sense, you are testing for continuity. In other words, you're trying to see if there was a kind of break at some point in transmission, if there is any place the wire disconnected or cut or something happened, and for some reason the conductor, it has deteriorated and it has to be replaced. So these are some of the tests that we run in order to detect faults in an electric circuit. Thank you for joining us in this lesson. To refresh your memory on what we've just discussed, please take the test that will appear on your screen.